well, we're going to go through real quick notes and check your understanding for 1.1b, all right, 1.1b, which is exploring data and displays. And so first off, let's kind of just define what these displays for categorical data look like, all right? Remember, categorical data is not quantitative. It's values that you take that cannot be easily averaged or cannot be averaged at all. So for example, each bar represents a frequency or relative frequency for each category. What this is referring to is a bar chart, all right, bar chart. You can see that up there, all right. This is known as a bar chart. We use bar charts quite a bit when we're trying to use categorical data and try to display it. Stack up bars to make 100%. Well, these stacked up bars is referring to a segmented bar graph. And we're going to talk about that right there. So we're going to talk about segmented bar graphs. And those are used quite frequently when you want to compare two sets of data. Sometimes it's a little bit easier than writing all of the different bar graphs and the bars there. Sometimes easier to compare. And finally, it's a segmented bar graph where the widths of the bar is proportional to the group size. Now, this is actually where you have different widths, and this is what's known as a mosaic plot. Okay, mosaic plots. Now, the reason why we have these mosaic plots, these bar graphs, these segmented bar graphs, is a lot of times is that we want to compare categorical data, and we have to figure out, is there an association? So, is there an association? Well, if knowing the value of a variable helps predict, just say predict, the value of the other variable. Okay, so you can predict. Not necessarily it's going to be actually what it is, but if you can predict something, then you probably have an association. And then how do you know you have association? Well, segmented bar graphs are associated, or they have some sort of relationship. If there is a difference in the graphs. So if you notice that there's a difference in the graphs, or they're not the same, then you know there's going to be some sort of association, all right? Are associated if there is a difference. So let's check this out, and let's check out that check understanding. So the following table gives us the results of a random sample of upper level students at Rocky Vista University. It is a mosaic plot. So if you look at mosaic plot, what you know is that we have a segmented bar graph where these are the percentages of each category. And the widths tell us how many people have actually been sampled. And so you can see the sample of juniors, just by looking at this, just kind of doing some previewing, is much larger than the junior class. So seniors first sampled, there's a larger sample of seniors than juniors. Okay, so what they did was they took the juniors and seniors. So here's our first variable. Okay, grade level. And then our second variable is employment status. And either they currently working, not working, but have a job, never had a job. And that's what we're looking about here. So first off, what we're going to do is we're going to calculate the proportion of juniors, all right, that are currently working, not working, but have a job, never had a job. So once again, we're going to use our margin, and we're going to be figuring out just for juniors, what is those different categories. So we're going to take the total number of juniors. And if you look at this, so we need that. So we're going to take 14 plus 22 plus 15. And so we're going to figure out that margin, which is 51 for the total. And we're going to take each one and we want to figure out what are they currently working and calculate those proportions. So we're going to have currently working. So I'll go CW, and that's going to be 14 divided by 51. And if you want to put that in your calculator, you get that's about 27, about approximately 0.27. Then we can go over here and figure out, okay, what is not working but have a job? So not working but job. All right, and that's going to be 22 divided by 51, which is approximately 43% or 0.43. So that's that proportion. And then finally, never had a job. All right, never had a job. And what we have right here is 15 divided by 51. Okay, which is approximately all right, 0.29. Okay. Now, next thing they ask us to do is calculate the proportion of seniors that are currently working, not working, but have a job and never had a job. So now we're going to do the same thing for seniors. All right, so these are for juniors, and now we're going to do for seniors. So currently working, we got to figure out the total number. So if you see this, we have 30 plus 40 plus 10, and we see that we have 80. And so as you can see from a Mosaic plot, there is a larger proportion of a larger number of seniors that have been sampled. And so we're going to have 30 divided by 80. And 30 divided by 80, that's going to give us 0.38. All right, not working but had a job. All right, and that's going to be 40 divided by 80. Now, the reason why we always want to use relative frequency in these cases, or proportions when we're comparing, is because the counts are different. It's important that we use relative frequency in our comparisons, and there's going to be a comparison in the end. Because just by looking at counts, that can be deceiving because there's a different total amount that has been sampled. So that's why we call it relative frequency. Just wanted to add that little comment while we're going through this. All right, then we're going to talk about 10 divided by 80. All right, 10 divided by 80 is that never had a job, and we're going to have about 0.13. All right, we have that right there. Okay, so now we're going to look at this and say, write a few sentences summarizing what the display in part A reveals about the association between grade level and job experience for the students in the sample. So grade level is going to be our explanatory variable, and what we have right here is job experience is going to be a response variable. Okay, so explanatory variable and response variable. So when we have this, is there some sort of association between, if you were in some sort of grade level, or junior or senior, what could you expect for a response? Is there any association? Well, in reality, if you look at juniors, it appears there is if you are an upperclassman or if you're a senior, appears to be a greater probability or a proportion that will have had a job. Okay, all right, sometime in the past. So seniors, so what we know is that seniors, let me write this. There is a greater portion of seniors who have or had a job compared to juniors. The proportion of juniors not having a job, or actually never having a job, is greater than seniors. And so what can we expect? If you sample a senior, you would probably anticipate that somewhere along the line that they have had a job before, okay? And actually, many of the seniors also are currently working. All right, you can also say that there is a greater proportion of seniors that are currently working compared to juniors. All right, and so it appears that the association is that seniors, all right, have, like I said before, have had a job compared to those that are just simply 1 year underclassmen of a junior. All right. Well, I hope this helps you out on understanding how to use plots for categorical data or different displays, and how you can use mosaic plots and doing some inferencing with association. All right. Well, good luck and God bless, and the rest of your problems.